Let's be real. Managing 3 project folders with your AI assistant is pretty straightforward, right? You give it a few simple instructions and you're off. But now imagine scaling that up. Imagine managing 30 project folders. We're talking research, active experiments, client work, automation scripts, the whole shebang. Suddenly, that standard chat interface completely breaks down. The AI loses the thread, it starts hallucinating file structures out of thin air, and you find yourself re-explaining the basic rules of engagement every single time you open a window. That right there is the absolute limit of standard AI chat. So in today's explainer, we are moving beyond those limits to explore a totally different approach, the AI Workspace operating system. We're going to look at how to treat your AI context not as a temporary chat history, but as permanent, rock-solid infrastructure.
Okay, let's dive right into this. Here is the blueprint for our architectural tour today. We'll start with part 1, beyond overloaded prompts. Then 2, the layered control architecture. 3, defining personas and tools. 4, memory and knowledge governance. And 5, the kitchen governance model.
Section 1. Beyond overloaded prompts. You know, early experiments with bringing local AI models into Markdown workflows were incredibly exciting, but they exposed a massive, glaring flaw. Without a formal system in place, the AI's context evaporates almost immediately. The fundamental shift we need to make here is treating context as infrastructure, because without a shared operating model, every single time you start a new session or switch to a different folder, you're forced into ad hoc prompting. You literally have to explain to the AI all over again who it is, what the project is, and what the boundaries are. Instead, we have to build permanent infrastructure. The environment itself should tell the AI exactly how to behave, so you don't have to waste time doing it.
Section 2, the layered control architecture.
So how do we actually solve this prompt overload? We do it methodically through a layered control architecture. This approach brilliantly separates where the agent is from how the agent should think. At the very top of our stack, we have the workspace.md file. Think of this as the global building directory for your AI. Before the model does anything else, it reads this root file to understand the big picture. It sets the global context, it outlines major project roles, and it establishes the working philosophy of your entire digital environment. Stepping one layer down, we hit the projectindex.md. If the workspace file is the building directory, you can think of this as the floor plan. It's essentially a master directory that lists all your project folders and explicitly describes what each one is actually for. Your AI reads this to figure out exactly which department it needs to route your task to. This ensures it doesn't accidentally start rewriting code in a folder meant purely for research notes.
Next up, we have the rulebooks, the agents.md files. These exist both at the global root level and inside individual local projects, and their job is to define entry discipline. They establish strict local boundaries, specify approved methods, and clearly mark out absolute do not touch areas. This is absolutely crucial because it prevents the AI from taking immediate, unscoped action and enforces strict safety boundaries across all your files. So, let's walk through this entry protocol step by step. I want you to imagine your AI as a newly hired employee methodically checking the company handbook before they're allowed to touch a single file. First, it reads the workspace file. Second, the project index. Third, it determines the correct project for the task. Fourth, it reads that specific project's agents file. Fifth, it checks the personas file for its assigned role. And finally, step 6, it verifies the scope of the task. Only after navigating this strict gauntlet does the AI actually roll up its sleeves and start working.
Section 3, defining personas and tools. Now that we've set the global rules, let's look at local boundaries. This brilliantly illustrates the difference between a basic, everyday chatbot and a true operating system. We're talking about the difference between blind agreement, where the AI is just a yes man stuck in an echo chamber, and independent checking. The personas layer allows the AI to adapt its style to become a highly useful, independent teammate. It understands your long-running context, it uses tools to test your ideas, it pushes back on weak assumptions, and it fundamentally refuses to just blindly agree with whatever you say. To really grasp how this functions, let's calmly map the external Hermes agent reference model over to our local Markdown first OS. In the Hermes architecture, you have a soul. Well, here, we have the personas layer. Hermes uses skills. We use toolmd files to cleanly store reusable, multi-step procedures. Hermes relies on memory. We use the LLM Wiki for durable, long-term facts. And the overarching Hermes agents, those align perfectly with our agents.md rules. It's really about taking these proven, powerful agent architectures and grounding them entirely in transparent, local Markdown files. Section 4, Memory and Knowledge Governance.
All right, we are now shifting our focus to the crucial concept of memory write-back. This is the magic that ensures your system actually compounds in value over time, rather than just wiping its memory and resetting to zero every single session. To understand compounding, let's break down AI researcher Eugene Yan's working principles. He argues that context absolutely must be infrastructure, not a repeated explanation. Taste and quality standards, those should be saved as permanent configuration files. Repeated manual work must become reusable workflows. But the real kicker here is that autonomy only scales when verification and checks scale right alongside it. And finally, finished artifacts aren't just one-off deliverables. They literally become the future context for your next task.
So how does this look operationally? Well, we can see it in practice through productivity expert Isar Huang's card box method. In this workflow, the AI acts as the interface for your local knowledge base. It processes raw sources, it transforms them into intermediate card notes, and finally synthesizes those into durable, lasting opinions. The AI manages the heavy lifting of sorting and drafting, while you, the human, retain ultimate responsibility for the goals, the judgment, and the final perspective. So the absolutely crucial point here is that this entire compounding process relies on one vital component, the LLM Wiki. Now, this isn't just another dumping ground folder. It is the central memory bank of your entire workspace. It records cross-project understanding, architectural decisions, and workflow rules. When a task is finally done, the finished deliverable goes right here, becoming permanent context. Which means your system literally gets smarter, faster, and more customized to your specific workflow every single time you use it.
Section 5, the kitchen governance model. To wrap this all up, I want to introduce a final metaphor that really clarifies how the system moves us far away from basic prompt control and into a complete, functioning workflow ecosystem. Think of your workspace as a high-end, professional kitchen. The raw sources, your URLs, PDFs, and initial data, those are the ingredients. The context routing we discussed earlier, meaning the workspace and project index files, acts as the receiving dock. It strictly controls exactly how, when, and where those raw ingredients are allowed to enter our workspace kitchen.
Let's move to the prep stations and see how this builds. Once those ingredients are safely in the kitchen, they need to be prepped. Your agents.md project rules and your tool.md files dictate the actual cooking process. They define exactly how those raw ingredients are cleaned, sorted, chopped, and cooked by the AI, ensuring that standard, high-quality procedures are followed safely every single time. Finally, we have the output. Formal delivery controls govern exactly how the final dishes are plated and served up to you. But a great kitchen doesn't just throw away its secrets at the end of the night, right? The LLM Wiki preserves the recipe. It logs the exact method, the course corrections, and the learnings for future reuse. The kitchen remembers how to cook the dish even better the next time around. Which brings us to the ultimate question you really have to ask yourself about your current daily workflow. Are you just typing one-off prompts into an AI, crossing your fingers and hoping for the best each time? Or are you ready to start building an operating system? A resilient system that captures your unique methods, respects your strict boundaries, and compounds your daily work into a massive, lasting asset. Thanks for exploring this architecture with me today. Take these blueprints, start with that root workspace file, and start building.